Well, hello everyone. Very warm welcome to you, and we're delighted to be back. 2026 is upon us, and thank you all for joining us for the opening session at Future Work Scotland for this year. We've got a really exciting, interesting session for you this evening, which I'll introduce in a second. And of course, Happy New Year to you all. And we wish you all the very best for the year ahead. We're looking forward to bringing you another very informative, educational, and inspiring series of sessions with some incredible guest speakers and thought leaders from around the world over the course of the year. The usual formalities for those of you who've been with us before, very simple code of conduct. We just asked everyone to be very respectful to one another. We want everyone to have a great learning experience. That is all we ask. And we'll do the usual community shout outs and updates at the end. We're going to keep the session quite relaxed. I'll hand over to our speaker in a second. As ever, if you have any questions that come up for you along the way, we will have the usual Q&A session towards the end, but drop them in the chat, prefix them with a Q, and we'll pick them up. And if there's an opportune moment for the speaker to pick them up, then we'll do that. And with that, I'm thrilled and delighted to welcome James Carpenter to Future Work Scotland. James, if you don't know James's work, James is very active in the less community. He's one of I think not that many less traders around the world, and he's been helping organizations to improve their product delivery for many years. Prior to that, he was a hands-on software developer, so that's his background, similar to kind of many of us. And we're thrilled to have him along today to take us through what is a very interesting case study looking at organizational culture design and the adoption of less with some actually very amazing, I'd say, incredible business outcomes. So looking forward to getting into that a little bit. So without further ado, I'm going to hand over to James. James, welcome to Future Work Scotland. You're on mute, James. Sorry.
Thank you, Seth.
Yeah,
It's a
there you are.
privilege.
There you are. Nope.
It's a privilege to be here. I've been asked today to talk about my last case study. And for those who let me share my screen real quick here. Um, if you go to the get this out of the way. Well, if you go to the less website, here it is. Over here, you see all these case studies, and if you go down to the large server hardware company, it brings you here. Um, there are tons of figures in this one with some detailed captions. A lot of people struggle to print it out easily from this page because it doesn't always format well. If you know to click on the audio versions, that text needs to be changed. It isn't yet. You will find PDF versions of both the full case study as well as the just the figures and the synopsis and whatnot. There's even an audio book. And for people who don't like using their home printer and still want to print it out, you can get it on Amazon, you can get it on Barnes and Noble, whatever you want to do there. So before we get into this, there's a key player in the case study, who's Mitya, who was the central director involved in the group that I did most of my work with, and that individual is here today. Mitya, you want to say hi?
Hello, everybody. Thank you so much for having me here and giving an opportunity to add to what James is going to talk about.
So I can say all kinds of wonderful things about Mitya, but if I say too much, it kind of messes up his anonymity. But senior director, uh, hardcore firmware hardware development for many years. Um, you know, working in Silicon Valley at various large companies. So nothing but wonderful things to say about Mitya, both professionally and personally as a friend. So anyway, I've taken the photos, or the figures rather, out, and we're going to just walk through them. And the intention here is that we give a quick overview of the case study, and then oftentimes the most interesting part of these presentations is actually the Q&A. And so we try to leave as much time for the Q&A as possible. But because most people haven't had the time to read through the whole case study, because it is such a beast of a case study to read, it seems to be useful to do an overview first. So we'll try to get through that quickly, answer any clarifying questions as we go along the way, and then please put really hard, nasty, thoughtful, deep, insightful questions in the chat, and then we'll have Donald or somebody curate them and once we get through the quick initial presentation. But don't hesitate to stop me for a quick clarification question there. Any thoughts before we go forward? Any questions?
I think
Okay.
you're good to go. I think you're good to go just now. Yeah.
You may want to send the link for those images and the link for the case studies in the chat.
Yeah, we'll do
That'd
that.
probably
We'll
be
do
a good
that,
idea.
actually. Yeah, no, we'll do that. We'll...
All right. Okay. So the overall context of this product, this is a server infrastructure on a forklift. It's a blade infrastructure product. So it has a blade chassis with a whole bunch of blades in it, and then this has an overall mothership that they all talk to that's able to do orchestration across the various blades, and there's also a storage layer. Mitya usually does a better job of describing this than I do. You want to talk about that, Mitya?
Yeah, sure. So yeah, as James described, a server product. So on the left side is the hardware representation. Many servers, some of them bundled together in the chassis as blade servers. Others are standalone, regular, what people sometimes call pizza box servers. And on the right side, you see the software stack. So starting from very top, the administration layer that can control many servers, many thousands of servers. And at the very bottom, BIOS and other low-level software components. And in between BIOS and this MCS administrator, other management software layers. So as a result, you have this. It's a tightly integrated system with software talking both north and south, all the way from high-level MCS administrator management layer, all the way to the low-level BIOS layer, and they're distinctly different components. BIOS is kind of an operating system on its own, written in C. I think James also describes it. James, do you want to describe?
Well, it's like you hold down in the primordial ooze. So you're writing C, but you don't even have the standard C libraries, and you're happy just not to be writing assembly.
Correct.
Whereas the BIOS code running on the Intel chips is talking to the node controller, which is light rate, runs on fly power, so runs on really low power, but it actually is a Unix stack, really stripped down, and it's the thing that's always on, because if you want to do administrative work to the blade, you have to have something to talk to, and the node controller talks to the chassis controller that talks to the administrator controller, and that's for your telemetry. And if you want to go, control functions go down the other path, go down the same path in the reverse. They go from the top down to the bottom. But from a software development perspective, or a hardware software engineering perspective, what I find very interesting is that when you get up to that top level orchestration layer, that administration layer, that is middleware development. It may well be, disguised as a pizza box pizza box firmware installation of a product, and from a perspective of a system administrator, it's just a node that they install or a device. But the truth is, under the covers, it's a full-blown server on stable hardware that is running a Unix stack, and the work that this is doing is the work of middleware flavor software. It just happens to be administrating a hardware infrastructure, but it could have been a trading system as far as like the technologies and whatnot involved. As you go down further and you get to the node controller, it's somewhere in the middle. It is, I think they were running Apache or maybe even, yeah, I think it was just Apache. I don't think there was a Java component. I think it was all C or all, there might have
Yeah.
even been some Perl or Python in it. But anyway, um, and then as you got down into the custom BIOS layers, this stuff is, definitely cross-compiled and deployed to target. It's they're using technologies, a tech stack from the early 80s, when Intel sort of standardized some of this stuff, except you did get the, what's the standard, the UEFI?
UEFI.
Yeah.
UEFI.
So there was at least a UEFI standard that came along, but their tool chain compared to the tool chain of, a middleware world was, it was Stone Ages, because there's only a few thousand people in the world that use that tool chain, and there wasn't much investment into it by the vendors. Um, Most of the BIOS code was indeed a third party would provide it. In this case, AMI, um, and they sell that to various OEM vendors of this kind of hardware product. Uh, but a tremendous amount of customization has to be made to that BIOS to introduce the control and telemetry information, so that what you want is when you slide a new blade, even into an older system, it has to implement all the protocols to be able to come up and go, hi, I'm a new blade, here I am, and it has to be recognized. And all that is custom proprietary protocols and handshakes and hardware connections and all of this. So there was enough customization that it was typically taking, I don't know, 30, 40 people a year and a half to make the customizations. So very detailed. Uh, Anything else we're missing there on the high level, Mitya?
Um, I think I'm not sure if this is now or later, but the development cycle of all of this is driven by CPU vendors' cadence of releasing new CPUs or upgrades um, to the existing architecture. Which, for example, at Intel used to be every 18 months there's a what they call tick-tock architecture. So every 18 months they come up with a new CPU architecture, and then next 18 months they come up with a improvement of the current architecture, and then the next 18 months they come up with a brand new architecture again. So again, James, I don't know if you want to
No,
go
go
to this
ahead. Go
now or
ahead.
later. Yeah.
Now, do it now to talk about the
So
importance of standing on stage.
yeah, the dateline, the the timeline of the release is really dictated by um, the CPU vendors, and this is true for all the server vendors in the world. When Intel or AMD release a new CPU, they spend a lot of marketing dollars on the CPU itself, and all the major OEM vendors kind of get on this bandwagon of publicity to also advertise the products that have support for these CPUs.
And failure to hit that window could lose 20, 30, 40% of revenue, right?
Yeah.
So we figured out of like a $4 billion revenue, we could lose we could lose $1 billion of that 4 billion just by not being ready in time.
Yeah, it would be close to catastrophic.
And that has been and unfortunately it was taking them they were flirting with that deadline every time, historically. Perhaps we should add a little bit more color. So I was brought in to look around the organization to see where there might be some opportunities for improvements. As I looked at the organization, and we had about 4,000 engineers, uh, it became clear there wasn't a single team that was doing anything close to, what a hardcore agilist would consider, modern agile development. Nothing like, XP style practices as self-managed teams. All of that was missing. Even though there was often lip service to it, but what it really meant was, just cowboy, do whatever you want, kind of. We don't need a process was usually what Agile was used as an excuse for. I'm sure y'all have seen that yourself. Anyway, so initially I looked for a component or an area where there was an opportunity to demonstrate what even just single team would do well. And it turned out that there was a diagnostic capability. This product did not have good self-diagnostics, and I think they were losing, like, I don't know if it was 100 million a month or something to hardware that would come back from the field. That when they got it on the bench, they couldn't reproduce the problem, but they had frustrated the customer enough that the account management had said, just ship them a new product, just ship them a new unit. And these are multi-million-dollar units. So here we were talking, hundreds of millions, not billions. But we knew we needed some kind of diagnostics due to some architectural aspects. It was an easy place to build a bubble, and so we built a cross-functional, cross-component team that had the testers in it, it had the developers in it, and it had developers that knew how to do all the work on the various pieces. So some of these were custom processors or custom chipsets. So like the NIC controller, I think is ASICs. So a lot of this was custom. The boards were typically custom, but we were able to find to have the general manager kind of twisted everybody's arm to cough up one person for this cross-cutting team that would be able to help build this diagnostic capability. And so we pulled them together, and here's the happy team, just a single team. And we demonstrate, and indeed, this does cut through the entire system, front to back. So it was very good in that regard. And it demonstrated that indeed they were producing truly shippable stuff every sprint, really more often than once a sprint. There was a compromise in the sense that they were able to provide an ISO that would do diagnostics on just an individual blade, and they could ship that to the field support people. They could ship that constantly. On the other hand, the ability to go to that orchestration layer GUI and say, let's take this big swath of blades and run diagnostics on all of that. You couldn't do that without integrating code into that upper layer here. And that was subject to, these slow release cycles of maybe every 6 months at most, because there's that 18-month cycle that Mitya discussed, but there would occasionally be, minor updates, software type updates. But the big updates were the ones that were driven by that Intel tick-tock. I got that right, didn't I, Mitya? You did do little minor stuff, if I remember correctly.
In this diagnostics?
No, just in general. In general, there was the occasional software upgrades to the MCS administrator and that kind of thing.
Yeah, in between cycles, yes.
In between cycles, yeah.
Yeah.
So the mid-cycle, there was some mid-cycle refresh stuff. Yeah. So that ability to address the entire set of blades, that had to wait for a release of that overall product to go out, which was definitely running on a waterfall style cadence. But at least this team could put out an ISO that could be used immediately to test individual blades, and that was way better than what they had before. And we could actually say, for this diagnostic, they had measurements from the field of, we will save this many millions of dollars per month by having this diagnostic, and this next diagnostic is worth this much. So it wasn't hard to stack rank which diagnostics they should do first. We had to do enough of a steel thread to make sure that we had end-to-end functionality working, and then it was just, okay, which diagnostics are going to give us the most bang for the buck first, and they would implement those. So this was successful. And while this was going on, Mitty and I were frequently having conversations in his office I'd drop by every day or so. Mitya, you tell this part of the story better than I do. You want to talk about this?
Sure, yeah. So I don't remember now from where, but I had this notion. I knew that we don't do agile, any kind of agile, less or Scrum in firmware. In BIOS, it's not done. It wouldn't work, and that was kind of the operating model. I had my own ways of managing the team, and it was working relatively well. So when James and I started talking, he started explaining concepts of agile, fundamentals of agile, really without the language of agile or less for Scrum, more in terms of what does each concept, each part of framework brings to managing the team, brings to product quality. And it became clear to me that a lot of these concepts that he describes are really codified approaches to how I manage the team in any case. And many of them are improvements, would improve how my ability to manage the team, effectiveness of managing the team, effectiveness of product delivery, and quality of the product. And so once this became clear, we started talking about how to go about transforming a team of 40 people. We had some in the US, here in San Jose and other areas, and some in India. How to all total maybe 40 people. How to transform this team from waterfall into an agile framework.
Yes. So thank you, Mitya. That's helpful. And so in order to make this happen, once I had Mitty on board, and it helped that we had a key director from that earlier effort come along. There was a lunch at the end. There was a key lunch that kind of crystallized everything. Mitty and I had been talking day after day for a long time, and finally we scheduled a lunch with a director who was involved in that initial single team diagnostics effort. And that lunch went, it was a working lunch. I don't know how long it took us, 2 or 3 hours. But when we were done, we were on board. Mitty was on board. And so then Mitty and I worked to train up all the teams, and then to basically launch everything on a given day. We did the launch event. For training, we had to do 2 cohorts in San Francisco area in order to train everybody, about 60 people. And then there was another group in Portland, and I went up there, I think by myself there. But I did have the director who was helping with the other effort. He was up there with me, so that was nice, in Portland. And then, so that took us, about a 2-week span, maybe it was 3, to get everyone trained. And then we did the launch event. And that took us a couple days to really get things launched. And then we made we were looking for how do we isolate this work. And we had the benefit of the teams in India that didn't report to Mitya. They were busy working on bug fixes for the BIOS related code that was already in production. So he said, let's take this new generation, which currently has people just in Portland and just in San Francisco that are reporting up to Mitya, so they're within his immediate sphere of influence, and let's improve our practices there. And since this group had been doing a fork for every new generation, and then doing copy paste reuse across these branches. And as hideous as that was, it actually provided an opportunity to say, well, at least we have isolation, we can build a bubble, and we can use the release version as one of our boundaries, if you will, for this bubble, which is what we did. And this allowed us to delay having to deal with the political struggles of getting the India team on board until after we'd already kind of proven that it would work better. And there were pluses and minuses of that strategy. Ideally, one would have had if you look at this from a feature adoption map perspective, historically, BIOS had, one or two people that knew how to work on one or two files in the system. And there wasn't even a lot of distributed knowledge across the BIOS teams that reported to Dimitri. Even that was very narrowly specialized. So just getting to the point that it was on the component boundary was better. It obviously was not ideal, and it was not this nice vertical slice to the whole system, as you see in the diagnostics. Was this much nicer slice in that regard. But it was the best that we could politically achieve. And we did immediately start to, once we got things running well, we were always doing the validation all the way to the front. We were doing that from day one. But we were looking towards doing more and more of the code changes as you go up that control and instrument and telemetry path, so that we would start to be making changes in MCS Administrator and the Blade chassis and in the node controller. We certainly had gotten blessing to do the node controller. So this is where we were trying to move towards, but we first had to get our own house in order. The reason that we couldn't have just done this day one, which would be the smarter way to do it, was due to some political struggles that we dealt with. So when we started for the first few months, we had this original GM who was there when I came in. And he was very supportive. He put me in an office next to his. The first meeting I ever had with him, he said, "James, the real question here is not what you can do for me, but how can I help you?" So I felt tremendously supported, and that was wonderful. And we did have all of these, that administrator system, that higher level orchestration layer. Those people working on that were reporting up through the software VP. And that person really didn't want to change. There's largely, passive aggressive kind of behaviors there. As long as we had this supportive GM, that was less of an issue. And, the hardware VP nominally is hardware, but the truth is it's a tremendous amount of firmware, and this firmware is as much software as anything else. It's firmware and, it's hardware and software. So there's a tremendous amount of software that's really under the hardware VP. But we had that support, and we later lost that GM just a few months in. So that was very problematic. But even then, even to start with to some extent, the reason that we had a compromised product boundary, and it didn't initially go as vertical as it should have, was because of this political dynamic with this passive-aggressive software VP. On the good side, we had a VP in charge of testing who was very supportive. So when we were training up the teams and launching the teams, they joined as team members of the Scrum teams like any other team member, and they worked on whatever work was on the backlog, was on the sprint backlog, just like any other team member. And the testers sometimes did development, and the developers sometimes did testing. So we started to, less at the beginning and more as time went on. We slowly rolled across. We started off, we think it was about 3 teams, if I remember correctly. And then after a few months, we would, as some of the other teams that reported into Mithya would come off, as they would come off of some of this production maintenance related work, we would roll them into this new work for the new product, or the new generation of the product. Eventually, we started rolling in the teams from India, which introduced its own dynamic that was problematic. Uh, a lot of what we did was some brainstorming to uh, even figure out we had such siloed information that we spent a lot of time uh, early on in the launch effort and then shortly after, and for a few weeks after the launch effort, um, getting that information out of people's heads and onto the wall, and sorted it and worked out what is effectively a product backlog of a sort. This is sort of a cross between a story map and a product backlog. It's really kind of a snaky product backlog that has some natural groupings of functionality. Um, Minty, anything I'm missing here? I'm kind of quiet, so I'm wondering if we might want to go to questions soon. Um,
I think no, I think you're good. I think you covered well. Do you want to go through just maybe add a little bit on the process of this like mapping out features and stories and
sure, why don't you do that?
yeah. So what I think what James just showed, um, the so as James mentioned, in the BIOS area in general, and this was definitely the case in my team and this team, that there are a lot of silos, a lot of specialization, and we obviously wanted to break that down completely. And while we let people naturally specialize in what they have been, we also want the entire team to be aware of not only which components make up the BIOS, but also what happens within each component to the detail of uh, features and functions. And so we went through multi-day effort, which was, this was an interesting experience. It was kind of a uh, mix of forthright excitement about telling everybody what a person's component is made out of and what goes into making it work, to on the other extreme, hesitation. Why am I telling everybody how this is going to work? My job security is affected by this. So there's two extreme and then everything in between. So it was but I think overall this was the team. It was largely facilitated by James and myself, but very much self-driven by the team and very much welcomed by most people. And another aspect that I think was interesting and kind of still stands out in memory is the definition of done. So again, while James has trained us on it, and James has facilitated the workshop of creating this definition of done, what we noticed both is that the team insisted that the definition of done is very tight, there's no room to slip things further from this sprint to that sprint, from this release to that release. They wanted things that they are working on to work. They wanted to deliver code that works without even minor defects. Of course, all of that has to be monitored with the timing of the feature velocity, and as I mentioned, the delivery date is set hard by external entities. But overall, we found that this helped us long term. And again, the um, the the strictness of definition of done was largely demanded by the team.
Yeah, that's definitely true, right? It's they had been frustrated by not being able to do as good a work as they had wanted to do for a long time. I think another aspect here is worth mentioning, which is this level of detail in a product backlog going this far into the future, in many contexts, that's not what would be advisable. Well, you would say, well, we want to do just enough to be able to get the product out there and start to learn. But here you had a context where a lot of what had happened, generation after generation after generation of this product, the teams have been copying code changes way down in a previous branch into the new branch. So there's been a tremendous amount of copy paste reuse without any sort of use of a pluggable layer, which is one of the things that they were adamant about, that they stopped that. So that shows up here. No core change. And no core change meant pluggable layer. That shows up here. No changes outside a pluggable layer, unless agreed upon as an exception. So what had happened is there was not much knowledge sharing of all of this knowledge. So that knowledge was in their heads, or, for any given thing, there were, one or two people that had great knowledge about that, but it had never been shared as a group. So this acted as sort of as much of an architectural knowledge sharing as it did figuring out what needed done. And also we were in this situation of a very hard release date of a semi-fixed scope. The truth is, as you can see actually here with that red line, there was negotiable scope. Below this, you probably couldn't ship it. You couldn't slide the blade into the chassis and have it be recognized and be at least comparable to the previous generation. Beyond that, you started to get into some nice to have features that would be nice to get out there, but were not critical. But below this, the thing wouldn't turn on basically. At least you would never put it in a customer's hands. So that's a little different than your typical, we're trying to discover the market. Here we kind of know the market. We're trying to do better engineering practices. And we also have a compromised product boundary because of these political aspects. And we have what is effectively Mitya is acting as a fake product owner, in the sense that the interface that we're dealing with was more of a technical layer, it didn't really go up to what it is that a business user wanted to do, because we didn't have a team that was capable of going to that level as we probably would have eventually have gone to. And I think had we not lost our GM, I think that would have eventually happened. Eventually, there were some massive layoffs. The hardware VP resigned and went to a startup that was recruiting people from outside from the company. And when everyone that was, including Mitya, started reporting up through this passive aggressive software VP, when we no longer had a GM that was as supportive as we originally had, that kind of was a death nail. That coupled with going from cutting half the engineers on staff. Unless there's anything else, we should probably open the floor for questions.
Yeah, I think that's a good idea.
Thanks, James. Yeah, fascinating. It's quite a complex. I think I'd mentioned it in one of my kind of promos ahead of this session. It's some of the concepts obviously are quite universal, and many of us have seen them in the different organizational contexts we've worked in. But to be applying it in that type of very deeply technical sort of hardware, firmware type context is, I don't know how many people have really kind of experienced that. I certainly haven't. I'm a little bit intrigued by you mentioned a few times around the political landscape of the loss of the GM, and obviously I don't know what that was about, and that's maybe not entirely fully relevant. I've read as much of the case study as I could get through in my available time.
It's a beast.
It is. There's a lot in there, but just to help get us started on some of the conversation, so there wasn't planned to replace that GM, whatever that was about, and then you were talking about the sort of the obstructiveness, I guess, of the software VP, who I guess was keen to maintain however you would describe that status quo.
Yes, he was very much vested in the status quo. And it wasn't the GM's idea to leave. So
Right, okay, that's what I
the,
was trying to get to. Yeah, okay.
the GM was brought in to help the Green Star GM was brought in to help change things, and this was, I think, just a few months before I arrived. Um, and then apparently he must not have done enough soon enough, or for whatever reason the political winds changed, and they sent this new GM who was there above the old one for a couple months, and then a couple months later you learn, oh, by the way, the original GM has now resigned, or was left, or like there was some transitional period at the end of which the the Yellow Diamond GM said, "Yeah, we don't need you anymore. You're redundant." um, and I think what was happening is, and it's covered in the case study to some extent, the original GM was an engineer's engineer. I think he may have had a degree from like it's MIT's. It's the MIT of India. The EIT, is it? Um, but heck of an engineer. Lots of patents on his wall. Um, the the new GM, although technical, because you can't be a GM of any flavor in this kind of business without having some technical acumen.
Hmm.
I would argue that this person was almost more of a VC kind of personality.
Okay.
This was a person who was focused on the money, right? And I don't think this wasn't a technologist that was going to like have had years of actual engineering experience and was going to uh, look for an engineer solution to solving the problem. They were going to look for a business venture capital style approach, or a private equity style approach to solving the problem internally, right? Um, uh,
You've kind of led me to the what I was curious about. You were talking about Mithya being a sort of fake product owner, and I couldn't help but feel wouldn't that GM, who obviously wasn't there very long, have been a really good candidate for being
oh
the
yes,
product owner? Yeah, and I
but
couldn't get that out of my head. I just wondered what your thoughts were on that. I'm sure
but
others might have
we
a view
also
on
had
that.
a head of product. So in a nearby building, then I had relationships with them. You'll see that on the graph as well. You'll see that. Uh, Here, let me share that screen again. Uh,
Because that was my thinking every time you like. So yeah,
so
given what you described, that would that not have been right? So that was could have been okay.
so
But that
this would have been
person
a
looks
very
more like
natural
A
product owner.
CPO, more like a CPO.
Yeah, that would have been a very natural product owner for an overall less adoption. That would probably be your product owner. Um, but and they were on board. They were friendly. Um, it was the problem was to some extent this person, and then the fact that before too long there is a C-suite that flies around in private jets, and this is just one division. Even though there's 4,000 engineers here, that's just one division of a very large multinational company.
Yeah.
And I've heard it. I heard it described by some people there that they leave you alone as long as the skim is good, as long as you keep funneling money up to the parent company. They let you manage it however you want. As soon as the skim isn't large enough, then they send someone else in to manage the casino. So I think that's kind of what happened. Um, but I also agree. My suspicion is that original VP, uh, if not this person, the odds are this person would be even better at it.
Yeah, yeah,
One of these two would be the ideal. But
indeed. Indeed.
what we were dealing with is a compromised boundary, really more of a extended component boundary, for which all the prioritization decisions required intimate technical depth to even make them.
Mm, yeah. Right, let's hear from our group. Any other thoughts, questions, surprises, things you'd like James and Mitya to maybe expand on? Now's your chance. This is a great but very detailed case study, widely available to the LESS community, but I think it has a lot of wider value as well, and I think it describes a lot of things that many of us see. So yeah, take the opportunity to explore it. No, no other thoughts, no questions.
I had a Magda. Is Magda here? Magda had a. Oh, she
Magda had to
disappeared.
drop off, I think, but she
Yeah,
she 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 did make a comment, didn't she? Yes.
yeah. But I was looking out, hoping she had a hard question, and she didn't. Um,
She often does have a good question when she's able to stay, but she sadly had to clearly drop off.
one of the things that makes the case study so dense is that the case study is not written the editorial intent of the case studies and all of the LESS case studies is not really to be a marketing tool. That is a secondary. That's a secondary objective. The
Okay.
primary objective of a LESS case study is to act as a mentorship scaffolding for the candidate LESS trainers, not unlike a doctoral thesis is used as a mentorship scaffolding for a doctoral candidate in the applied sciences. By the time that a doctoral candidate gets in front of the panel defense where they do the verbal defense, well, the professors already know how the kid's doing, right? I mean, they've already tortured the heck out of them through multiple rounds of edits, right? And this is used the same way. So you spend hours and hours, well, days maybe, with in my case with Craig Larman over the course of months and months doing multiple rounds of edits. And before that, my initial the first pass was with Victor Gregaric. I'm very grateful to have had, and that's the same thing. And so that's one of the reasons these things are so long, is because you're looking to clarify the thinking of the LESS trainer candidate. Which is also why you'll find that the LESS trainers are vetted to an inch of their lives.
Yes.
So that's for good and for bad. It's it can be a painful experience, but
I can imagine.
you
Well,
experience some of that pain as you read the case study.
it's rigor
So
in the process, right? Therefore,
yeah.
a high bar is being set.
But if it
So,
reads as a dry thesis, well, yeah, that's because it is. Um,
yeah.
uh,
Any other thoughts, folks? Sheila, you've come off mute.
Yeah,
Maybe
I'm.
could you?
I just got kind of stuck, and they wanted copy and paste. They didn't want anything to replace it. How could they possibly even defend that? Because that's so error prone.
Mitty, I'll let you address it. Mitty will explain this is common in hardware.
Copy the paste code, you mean?
Yeah.
Yeah.
So yeah, so this maybe goes back to, we need to maybe step back a little bit. What happens along the refresh or redesign cycle of the CPU, the BIOS vendors that provide the underlying BIOS code, reference code for all the OEMs, they take the opportunity to redesign parts or a lot of their BIOS common code. So unless the code is architected, your own code that you're adding to the BIOS is architected in a way that is completely outside of the BIOS vendor's code, you end up with pieces of your code embedded in the code that you have received from the BIOS vendor. And it comes from for two reasons. One, as you can imagine, something is in a rush, something gets implemented, and it's easier to implement it in place rather than architecting some kind of API and putting it outside the whole BIOS core. And then once it's there, and it gets carried over and over and over until you find some kind of time to address the technical debt. So that's one reason. Second reason is the BIOS vendors are not perfect in providing enough hooks, enough APIs to have that code outside of their core code, because it's it's kind of like, imagine it's you're writing code on top of an operating system. In this case, operating system is the BIOS core code. However, your apps don't have kind of well-defined interface, like an executable file or like a file you can, like an executable file in an operating system. So you end up looking for a good place in the operating system to place your code so that the operating system behaves in a certain way. So those two things, one, again, just to repeat, one, and I'm not sure which one is first, which one is second, but so one of them is when you don't have enough time, when you need something quickly, you do end up taking a temporary shortcut, unfortunately, and that temporary shortcut gets carried over, like in any other software. You implemented something and it carries over as technical debt until you have time to address it. And then a second one, oftentimes a bigger problem, is the BIOS vendors continuously work on improving their SDK, improving their APIs, but yet they can't provide for all the situations. An OEM may need to customize it and provide hooks and APIs for everyone to do very specific, often, things. Hopefully that makes sense. So that's
I think what you're saying is it wasn't really just a straight copy and paste. It was something where they had to do some analysis and determine how to integrate the code.
So I think copy paste means, so let's hypothetical, not so hypothetical, not exact example. So let's say I am working, let's say my feature is to change a boot order or change memory initialization, some kind of customization to memory initialization. And this customization is specific to my product, specific to my brand. This is how brand X, brand A does memory initialization, and what this, our brand, let's say, does with, I didn't mean to say X as a company X, this is before X. So this is how our product deals with different things in memory initialization, and perhaps it's unique. So how do I do it? I write some code, and now what do I do with this code? The easiest choice is to take reference code from a CPU vendor. It actually is not even BIOS vendor, it's a CPU vendor's code, and then add my code to it. And I have some functions, and so the copy paste here refers to, maybe it's not exactly copy paste, but it's taking my code, and then, so now I know the code I need to port. Actually, we use the term porting. So I have my code from previous generation product, and I need to port it onto the new generation product, which comes with a new BIOS, which comes with a new reference code from Intel or AMD, from a CPU vendor. So that's the process of what James referred to as copy paste. Maybe porting better description is porting from one to another.
And the extent to which that ported code is the same or different than the previous generation of the product is a function of several things, including has that BIOS vendor, or in some cases the CPU vendor, have they recently made changes in that part of the hardware architecture or not, or the software architecture? It could be either one. And then another aspect of whether there's a pluggable way to do this such that it would survive multiple generations, that depends upon the those supplying vendors that are supplying you that AMI BIOS, or in this case, or either the Intel code or the AMI code. It requires that they have thought through in an appropriate way and given you a pluggable hook in order to do your functionality, give you some sort of pluggable layer. And it wouldn't be surprising that that too has evolved over time. And so maybe when this group that the case study covers, maybe when they initially did this work, there wasn't a pluggable layer to be had. And they were under tight time constraints, and you could go back and beat up AMI and say, we want a pluggable layer for this. And perhaps there wasn't time to do that. And or maybe they didn't. And then there's also a cultural element within the hardware space. You may in a middleware space, you get used to with proprietary code, oftentimes proprietary libraries. Oftentimes, you're given the library. You may not have the source code to the library, especially like when they're proprietary libraries. You'll have the APIs, but you won't have access to the internals. In a hardware world, it's very normal that the supplier gives you all of their source code. And it's also very normal that someone who's using that has to make a few tweaks based on whatever subtleties they have different in their hardware. And then another kind of overall cultural influence is oftentimes these are electrical engineering majors. So they may be fantastic at understanding the hardware, but they may be very sloppy when it comes to good software engineering practices. That doesn't have to be that way, but so there is a need for cross-pollination of good software engineering practices with good hardware engineering practices, and oftentimes you end up with teams that are a bit lopsided, and your systems reflect that. There was a question on the.
There was. I was just waiting. I was just waiting for you to finish that. So it was about edge cases from Greg. Greg, thank you for the question. So yeah, essentially what Greg's saying is it feels like an edge case. To what extent is any project like this about dealing with edge people, i.e., those who are not conforming, maverick, or idiosyncratic? Great word. People thoughts. And Greg, also feel free to unmute and chip in if you want to have a bit of a dialogue about it with James. But that's the question, really.
Yeah, I have an answer, but I want to hear Greg if he has anything else to add first.
If he's willing to come off mute and wants to share more. Can you hear us, Greg? There you
are. Yeah, I can hear you fine. I've been thinking about groupthink and the possibility that some kinds of project or some kinds of situation may become so dominated or overwhelmed by groupthink that it can ruin the project. I'm thinking about this is very off topic, really. But I'm thinking about the two shuttle disasters. I believe they were both due to groupthink, a really entrenched kind of malicious, well, that's not the word, not malicious, but pernicious groupthink that was very hard for anybody, any individual, or even a small group of individuals to overcome. And those are two terrible disasters. So, I mean, that could be applied to any project, I suppose. We've seen so many UK government projects, IT projects, fail rather miserably. And it's possible, just to finish up, it's possible that the idiosyncratic people, the mavericks, are the ones who can maybe counter the groupthink. But in a lot of cases, they'll just spoil the pudding, so to speak, like the passive-aggressive person you talked about. And I agree that's probably always damaging, passive aggression.
So I have an opinion here. I have a strong opinion on this one. In fact, it's central to the message of less. Culture drives structure. Or if you like Deming, every system is perfectly designed to get the results that it gets. Or if the other one, the older, is something to the effect of, if if the flowers are not blooming, don't blame the flower. Fix the garden conditions if you wish to have a different outcome, right? I'm quoting that one wrong. That was an older quote. So usually there is a structural reason that you're getting the outcomes that you're getting. And if you wish to fix them, you can't, talking about mindset and value system won't move the needle. If you change how the org is built, if you change the incentive systems, if you change the reporting structures, if you change how the teams are, if you have teams are either, take this with a grain of salt, but you're either fully empowered, self-managing teams, or you're not. There isn't, this is kind of like, I guess it's okay to say you can't be half pregnant, right? This is to some extent you have to be. The teams are truly in charge and able to take a business product and understand the business need and go do that thing, or you're trying to macro manage the heck out of them, and usually it's one way or the other. And if you want teams that really don't have many of these problems, the solution is the same as it's always been throughout history, which is you take all the smart people that you need that have the expertise in the various aspects, both skills and knowledge of the different subsystems involved, and you give them clarity of mission intent and give them permission to go at it. And this is what less does. This is what better approaches to Agile have done. This message is not unique to less. The only thing that's unique to less per se is the fact that where a lot of approaches to Agile focus on the process flow mechanics, they don't really deal with the deeper organizational structural issues. Less goes there. And deals with that in a way that other approaches don't. It actually changes the underlying structural, underlying power dynamics. And in fact, the success and the failure that you see in this case study is directly attributable both to the extent to which we were able to build these self-managing teams that, at least within the context of BIOS, were able to manage themselves and collaboratively go forward. That contributes to the successes, and the failures are also attributable to failure to address the structural issues and the incentive issues above the team level. And the case study is very transparent about that issue if you read into it. I think in the conclusion section, I say something to the effect, it's as if I had the soil conditions were such that the soil was good enough, deep enough for the plants to start to grow, and you start to see the fruits of what's possible, right? You see all these sprouts, and you see the wonder that is possible with better organized team structures, and yet within a year it runs into this hard rock layer that chokes out the very plants that we're trying to grow because we didn't deal with those deeper issues. Now, there's all kinds of reasons that didn't happen, and you see those politics of changes in the management structure. Most organizational change efforts are one executive management change away from failure. Perhaps there's ways around that with companies that are owned by the employees, and there may be other organizational ownership structures that would resolve that. But for your typical corporate organization, that remains true. You're typically one senior management change away from things falling apart, and this is no exception.
Yeah, that's terrifying. Yeah.
Well, it's reinforced, so this was beat into me. It's one of the things that became very apparent to me as I spent all this time as a candidate less trainer back in the day. And, Larman just drills this into you, and he's right. And then every time I run the less practitioner class, which is a whole bunch of system modeling, um, just the modeling, you just when you see it in the system model, you're like, so many of the problems are rooted in deeper structural changes. And if you really want to fix them, you have to understand how these deeper structural forces interact with each other. And then you have to go change the stuff that actually matters, and which is these deeper structural issues. And if you change these structural issues, you will shift the power dynamics. This is both why less works and both also why it is such a threat to the status quo power structures. So it's, you want to change, you want to get better. Okay. How bad do you want it? You could say the same thing about me in an exercise regime. How bad do I want it? And and that's the problem. Uh, any other questions
Of
or any
course,
reflections on that, Greg?
the converse would be that installing the right person would make all the difference in making something succeed. So it could work either way, and I
It could.
suppose the thing to do is work fast enough in either direction or the right direction.
The
Anyway,
question is,
that's me.
why is it not stable, right? Why do you get a leader who does demonstrate the kind of principles that you want and does create a much more effective organization, and then their replacement never seems to be the same, right? Um, I think that's interesting. Why does the organization perpetually? Why is that not uh, a stable condition? Why does great leader not beget another great leader?
Yeah.
Um,
And I was thinking about the really big projects. Well, I just finished watching Oppenheimer, the film, and that's an example of a huge project that had to succeed. It could have failed in all kinds of ways, and yet it did succeed. Likewise, the Apollo project, led by was it James Webb? Um, Either of these could have fallen flat in their face if it went the wrong way. Anyway, I know I'm probably digressing a long way from the main theme
no,
of
that's,
your.
that's that's okay. Um,
Mm.
any other deep thoughts in the room?
No other questions in the chat, but no, thanks for that contribution, Greg. I think that was an interesting point that you made, and I think it draws light to the fact that, irrespective of, method, framework, however you try to approach things, the systemic challenges are always going to be the barrier to real progress. I think the thing that I find really almost reassuring and quite fascinating about the case study is the economic value piece. Because most of the time when we're doing what we're doing, right, everybody's like, well, where's the value in this and what outcomes were achieved? How did we move the needle? But to be able to articulate it in that way with that type of financial reward, if you will, I think it's something that others do need to be aware of to go, actually, agile practices, etc., can help you do this sort of thing because we've all seen, some of the bad rap that agile
I
has got
think
over the piece. That's the bit I kind of, to be honest, I'm drawn to and I really like about the whole thing.
I think one of the challenges, Seth, is that the actual personal incentives for
Hmm.
people in management, especially middle management, but it could go higher, is their actual incentives are not really delivery of greater value to the end customer. There's a lot of incentives to actually give lip service to that, but actually build yourself a little pyramid. And the more people you have reporting to you, the better your own personal wealth aggregation is.
Sadly
And
true.
and that's the fault of whoever's creating these incentive systems to drive that behavior in the first place. So you have to fix those issues as well. Now, in my case study, we did not fix those, and we suffered the consequences of not doing so.
Hmm.
But if you really want to fix it, um, you need to fix this. You need HR in the picture.
Agreed. But I think often that will always be the determiner. How are people incentivized and how is performance measured? Right. And that I don't think that will ever change. And if you can get that right and incentivize performance which aligns to ultimately what the organizational goals are, then I think everyone wins, right? Ultimately your
Yes, yes.
customer,
I
which is
think
your
if you
customer
have a
wins in that.
situation where doing the right thing for the business and for the customer is also the right thing for your own personal benefit,
Yes.
even not professional career growth as well as financial compensation, then yeah, this will be much less of a problem. Uh,
Agreed.
I agree. What I find fascinating is the extent to which people they want to be part of something bigger so much that even when the incentives are not ideal, you sometimes get great behaviors. In spite of the structural reasons,
Hmm.
and that's interesting. Um,
No, agreed. I've certainly been in environments where I and others were motivated by what we were trying to do, and we knew it was good for the organization, or the outcomes that the area of the organization that I was in was trying to achieve, and you would kind of do them anyway because it was the right thing to do, and there were positive outcomes associated with that. So there's that balance between what gets cascaded down, and what is, determined by traditional positional authority versus being able to influence without really having authority, which I've always been quite motivated by, in all honesty.
and you can't boil the ocean, so you have to
Yeah.
say what's doable, right? And you focus on where you can have influence. And
So that was my other point quickly, because there's no other questions, and I'll probably start wrapping up in a minute because we're getting up on time. But I was intrigued. There was a middle bit where you admit you were talking about, like, there were a certain minimal amount of things that you essentially had to do, or you couldn't bring a blade online, right?
oh
Because it
yes,
would. So I started to think about, the traditional concept of a kind of minimal viable product. But do you think you'd work in that way? Because that wasn't clear to me, and I didn't know whether I was barking up the wrong tree there. But
so here you have that blade chassis wants to speak a protocol, right?
mm,
And has a given hardware interface. And at a bare minimum, to be able to slide a new blade in that's built with a new blade architecture with a newer processor, etc. At a bare minimum, it has to speak the same. It has to be capable of the same functionality that the previous generation of blade was. And in fact, that was probably, I don't know what, 90% of the work. It was the majority of the work. And then the extra 10% of the work might be, oh, they added some new capabilities. Well, let's make sure we support those new capabilities as well, right? But a
mhm.
lot of it was just, can you plug it in and it works at least as well as the old thing? Otherwise, you would just buy the old hardware. You wouldn't want the new half, here's a car with two front wheels but no back wheels. It has to kind of be enough to
Yeah.
be viable.
So that was
Um,
the kind of fixed scope, but the last bit you mentioned there was essentially the negotiable fixed scope piece you
the
talked about.
negotiable is can you support all the new bells and
The
whistles that
new
this
bells and
thing
whistles.
has, right?
Yeah, yeah, okay.
And even if you failed to support all of them, we talked about these mid-cycle refreshes, mid major, within these 18-month TikToks, there were
Mm,
mid-cycle refreshes. So if there was just a little bit of a software, oh, maybe 3 months later you could update the software that did that, you know. But you at least have to be enough that Intel lets you stand on stage, right? And this
mhm,
sort of context, you would see this. So we've talked about this in a server hardware infrastructure. I could see the same sort of thing in self-driving cars would have the same kind of complexity.
mm,
So would uh, you could see radiation therapy equipment might have, or MRI,
okay.
imaging. You might have low-level detailed components as well as high-level software, and have this, mix of uh, mix of engineering disciplines as you go up the stack. Um,
Nice.
I guess probably I should mention an interesting segue for all this the systems thinking part is I guess I should mention the course.
Yeah,
Um,
I just want. It looks like Sheila's come off mute. I don't know, Sheila, if you had
oh
a
yeah.
question, because we could probably pick up one last question, and then,
Well,
as you say, James will wrap up.
it's more of an observation.
Okay.
One of the questions was about edge people, who aren't quite conforming or mavericks or idiosyncratic. And it sounds like the person who was the champion for this effort fell into that category. And that was the make or break thing for it to go forward. And when he left, it fell apart. But the thing is that people in general don't like change. They want everybody else to change, but they don't want to change. So when you're
Yeah.
trying to change the way you're doing things, even if whether it's a new product or a change in the organizational structure or in the way you're going to approach problems in the future, those are all changes people don't like. And eventually the visionary does get pushed out. A lot of times you see that. And I don't know what you do about that, because if you don't continue to evolve as an organization, I mean, that's one of the things we do talk about with Agile, is that if you don't continue to evolve, eventually it stagnates and dies, the organization itself. And
Well,
I don't know, but that's the basic challenge we're really dealing with.
I have a thought on that. Um, so I grew up on a farm. In fact, I'm on the farm at the moment. Bunch of cows outside, and but this is true in your garden. If you want a certain thing to happen in your garden, you want to have grow certain types of crops, then what you do is you create conditions appropriate to that. Now, if we talk just about our yard, you probably don't want a lot of weeds in your yard and whatnot. And it so happens that the weeds that tend to have those nasty stickers that you step on, they germinate pretty high off the ground. So if you mow the yard every 2 weeks, then they never get a chance to grow high enough for that seed to germinate and to produce the sticker, that you step on, right? So what you've actually done is you've enforced a given set of growing conditions. And in this example of grass, the grass that you want, you've created conditions that it's going to thrive. It's going to go, wow, I love this. I love this new condition that we're in. I no longer have, weeds competing for I no longer have these stickers competing for my light or competing for my floor, my water and everything. But if you're that sticker who's getting your head cut off every time that mower comes by every 2 weeks, then that's quite frustrating. So what actually happens in an organization is you create, or executive management creates the garden conditions. And then those garden conditions will naturally amplify and de-amplify certain characteristics. And so these certain personality types or belief systems or behaviors that you don't want will start to disappear, not because they naturally disappear, but because this constraint is being held on this organization, and the behaviors that you want will start to appear. So if you create an organization where the structural forces enforce, there's lots of incentives to collaborate as a team. There's enough transparency that malicious behaviors are become obvious. So that kind of detracts from that. And people who are used to climbing the ladder by doing all kinds of nasty behaviors, well, if there's enough sunlight, it's harder for that to be true. So I guess at some point, and maybe this is the farmer in me, you come to accept that there is going to be certain environmental conditions. The thing you have to decide is what is it? What is the type of crop that you would like, and how do you create conditions that are conducive to that kind of thing? Uh, and know that people who are not a good fit or behaviors that are not a good fit, they won't be happy in that. Whereas another group will be, because hey, now it's safe to do good engineering, etc.
Does that help, Sheila? I'm just conscious I've only got a few minutes left, and as you know, because
I think it's a
you're with
long
us regularly,
discussion,
it
so I
is,
don't think
yes.
there's an easy answer. That's why I said it was an observation, not a question.
Oh, I'm sorry.
Yes.
Okay.
That's okay. I mean, definitely, you could. I was expecting a response to the observation, but I didn't expect a solution.
Well, it's not a solution. I mean, the solution,
Bonus.
you have to first understand all these forces and say, okay, what kind of
Yeah.
environment is conducive, right? This is where system modeling is so useful, to help you understand these deeply. So, because once you understand it, then you can start to do something about it.
Yeah, well, and
Um,
the thing, and you got to go back even further because the thing you're calling a weed and cutting the head off of apparently has some medicinal properties that are actually very, very beneficial, and it really shouldn't be considered a weed. And that's that. So we can go way down a rabbit hole with that.
that's right. A farmer hates Bermuda grass. Dad with a bunch of cows loves Bermuda grass. So it depends what you're trying to do as to what is and isn't a weed. Changes on context.
Yeah,
Yeah, very
so
much
that's
so.
why I said I didn't expect a more than just an observation and a response.
Oh, okay.
That is good. I'm gonna start bringing it to a close because we are up on time, and we always like to stick to our time box to respect everyone's time. James, do you want to quickly just talk about what exciting thing you've got coming up for everyone's benefit, and we'll also circulate some of that for you. Then I will just wrap up.
Sure. So I've been looking around at where on the planet. So if I'm getting ready to run a certified less practitioner class in this few different cities around the planet, and I've mostly been looking for places that currently nothing is being offered. So there's nothing in Switzerland. There's nothing in Scotland. There's or UK in general. There's been nothing in Ireland, and then not until Boss has a class late in the year is there anything in the U.S. So I do have a class listed in Dallas as well as one fairly close in New York, fairly close to Sheila there. Um, so, and what these classes are is a lot of it is system modeling. It is thinking through how do different organizational design choices influence outcomes. The system optimization goal of less is explicitly highest level adaptiveness in the service of learning and delivering highest level value. And so that system modeling activity on large whiteboards, which I fly with, um, that is that isn't really about less it's per se. It's really just organizational physics, if you will. The kind of thing Sathpal keeps mentioning here. These kind of true no matter what kind of label you put on things. And then because this is a less class and because we don't have time to compare a whole bunch of different choices, um, we look at concrete specific choices that have been made in less. For example, what are the less rules? But not just what the rules are, let's reflect on the system modeling and come to an understanding of why did Boss and Craig make the choices they made. Um, and the system modeling, which is agnostic of any particular framework, will explain why this new approach to designing an organization, or it's not that new, but this approach to designing the organization, why the specific choices were made. And so this is a 3-day deal, and I have one running in uh, these 5 locations now. So Zurich is in Feb 17th, Edinburgh is on the 24th, Dallas is March 2nd, New York is March 17th for the 3 days, and then Dublin is the 24th. And you can also find these on the LESS website as well as my own website. And each of those has a critical mass that they have to achieve. The early bird tickets, once the early bird tickets are gone, then we know that it will run. So that's the thing. Let me stop sharing here. Trying to get back to the meeting.
Yeah, great. No, that's good. I am conscious of our time, and we're starting to overrun a little bit, but we'll circulate that for everyone. Obviously, as James has said, there's a few different locations, and as he's rightly doing, he's looking to support the communities in a number of different locations where there's perhaps an opportunity to feel like people benefit from all that Les offers and the system modelling that he's talked about. And I've hosted James before in one of my other community endeavours, so I'm familiar with the experiences that he brings to these things. So I would definitely encourage others to think about it, because there's a lot of value in this stuff. And as most of us know through the work that we do, organisations are still more often than not failing to solve the holistic problems in the organisations. Right, James, I'm going to take a moment just to thank you kindly for your time.
Well, thank you.
It's been excellent to host you again. I thoroughly enjoyed it. I think it's a meaty, challenging, quite complex problem space that you brought to the group today. I'm sure many others who couldn't join us today will pick it up in the recording, and hopefully reach out to you if they have further questions, if that's okay with you.
Of course it is.
And I think Mitya's had to drop off, but also thanks to Mitya for joining you and being a kind of secondary guest for this particular opening session of the year. So thank you again. It's been great to see you, and thanks to you all for also joining us, supporting the session and engaging with your thoughts and your questions and your contributions. Obviously, we're just opening up a new year. Donald and I are building up our program, as many of you will be familiar with us doing. We already have a few exciting sessions imminently about to drop, as it were, for Q1. So look out for those. The next one will be with Tutu Arayo. I'm not sure if I'm saying her surname correctly. A few of us do know her. Donald and I did a workshop with her before. She does some interesting work in the sort of exec coaching space, and she's launched a new book, which is really about her own lessons in her 50 years. So it's quite a nice sort of personal anecdotal piece, but there's lots of really good leadership takeaways and transformative bits and pieces in there. So we're currently working up a session with her. Looking forward to announcing that probably in the next few days or so, failing that early next week. And we'll also have Sean Blair joining us for a session in March. He's got an interesting new book, and again, very topical. He'll be talking about his book around system synergies, but really about the very fact that we still very much need human intelligence, and we cannot be replaced by artificial intelligence. So I'd imagine that topic will be very popular, and he's doing a lot of great work in that space and has been very vocal about it all. So looking forward to bringing those to you all. So look out for them in Meetup pretty soon. And again, thank you for joining us for the opening session of the year, and we look forward to seeing you over the course of the year at other sessions that we bring to the community. So yeah, enjoy the rest of your morning, your afternoon, your evening, and looking forward to seeing you again soon. So thank you all. Take care, and
Thank
thanks
you.
again, James.